So before we dig fully into how to use this systems of equations, we need to talk about this row echelon form, which we talked about last unit with systems of equations, and also this thing we're going to call reduced row echelon form. So a matrix is in row echelon form has the following properties. The first thing it says any rows consisting entirely of zeros occurs at the bottom of the matrix. So if you have one row, anything horizontal, which is all zeros all the way across, we're just going to make that all the way, put that all the way at the bottom of the equation, so or bottom of the matrix. For each row that does not consist entirely of zeros, we're aiming to have the first non-zero entry to be 1. We're going to call that a leading one. For two successive rows, the leading one in the higher row is further to the left than the one in the lower row. Ooh, that's a lot of info. The last part we're going to say is a matrix is in row echelon or in row echelon form is in reduced row echelon form if every diagonal that has a leading one has zeros in every position above and below its leading one. That's a lot. Let me write down a couple things here. So for the second one, it says each row that does not consist entirely of zeros, the first non-entry it must be a 1. So an example of that could be a matrix that looks like this. Maybe it's a matrix that's 1, 3, 6, 0, 1, 1, and 0, 0, 1. So each first entry in the row, the first non-zero entry in a row is a 1. Also, in addition to that, the reduced row echelon form would look like this. It'd be 1, 0, 0. So 1 followed by two zeros, 0, 1, 0, and 0, 0, 1. So again, above and below the leading ones are only zeros, and technically to the left and right of the leading ones are also just zeros. So it's worth noting that row echelon form of a matrix is not unique. You can get multiple row echelon or multiple matrices that have the exact same row echelon form. Now, the reduced row echelon form of a given matrix is unique. So that one we're going to have to get specific, unique answers. This process we're going to do, getting into row echelon and reduced row echelon form, is called Gauss-Jordan elimination. It's going to take a little bit of work, but we're going to try it out. We're going to make it work. We're going to use some strategies that we've used in the past. So we're first given this system of equations, and yes, we have a fourth variable now. It's w. Last unit we used only x, y, and z. Now we're adding in w. So we're going to first take the system of equations and make it into an augmented matrix. So an augmented matrix, again, has the same number of rows. So this is going to be 4 rows. And the number of columns, you're always going to have one more than the variables. So kind of like putting that into perspective. We're going to have a column for x's. We're going to have a column for the y's. We're going to have a column for the z's. We're going to have a column for the w's. And we're also going to have a column for our constants. So going through, I usually just do, well, it really doesn't make a difference. Sometimes I do the rows first, sometimes I do the columns first. I'm going to do the row first, so x plus 2y minus z, and then you'll notice there's a blank there. I'm going to do it as 1 for our coefficient for x, 2 for our coefficient for y, negative 1 for our coefficient for z, and then 0 for our coefficient for w. Sorry, waiting for air server to catch up. There we go. And I'm going to draw a dashed line here because that's going to separate it, and we're going to put the constants on the other side. And our constant for our first row is 2. For the second row, sorry, waiting for air server to still catch up. There we go. Second row, our coefficients, our x has a coefficient of 0, our y has a coefficient of 1, our z has a coefficient of 1, our w has a coefficient of negative 2, and our constant is negative 3. For the third row, we have coefficients of 2, 4, 1, negative 3, and a constant of negative 2. And for our final row, we have 1, negative 4, negative 7, negative 1, and finally negative 19. Yikes, that's a lot. Now I will say that looks like a lot, and it is, but it's a little cleaner than having to write 1x plus 2y minus z, and then, oh my goodness, writing all that. So this is going to be a slightly simplified version. Now, in general, again, we're looking for it in the end to be in 2 different places. We're going to start by getting our diagonals to be 1s. So I'm going up to the top here. Once air server picks up, we want the diagonals to be 1s like we talked about in step 2. And then after that, we want only to have ones and diagonals. So what I'm going to suggest is get ones in our first column. So let's focus on just this first column here, just what is currently our x's. So we got 1, 0, 2, 1, and that's it. So we're going to try to keep that 1 there in that top left corner. We're going to try to get zeros below that. So to do that, what I'm thinking about doing, and I'm probably going to do this in more steps than we normally would, I'm thinking for row 3 there, let's add -2 times row 1. Now leave a little bit of space off to the right here so we can show off what we do for our work. So I'm going to draw an arrow saying, okay, we're making it into this new matrix here. And we're leaving that first row alone, 1, 2, -1, 0, and on the other side are constants of 2. The second row, we're not doing anything with that right now. We got 0, 1, 1, -2, and -3. And for our third row, we're going to take -2 times row 1 and add it to everything in row 3. So we're going to take -2 times 1, add it to 2. So we got -2 plus 2 giving us 0. That's the goal. We're trying to get zeros in our first piece there. Then we're going to do the same thing for the 2. We're going to take the 2 here, multiply it by -2, and add it to the 4 down here. Well, 2 times -2 is -4. Adding that to 4, we get 0. That's really convenient. So we're going to put that down. Then we're going to move on to the next column. We're going to say -1 times -2 gives us +2. And now we're going to add it to the 1 down here. So +2 plus 1 gives us a grand total of 3. And then finally, or not finally, goodness gracious, I'm getting ahead of myself. Then we're going to take the 0, the 0, multiply it by -2, which is still 0. Add that 0 to -3, we got -3. And we also got to do it for the constants on the other side. So we got 2 times -2, which is -4. Add that to -2, and we get -6. Now we have not done anything with that bottom row, so we're just going to leave it as 1, -4, -7, -1, and -19. Now, one thing that we'll probably start doing more later as we're getting more and more comfortable with this is doing steps to multiple rows at a time. So if I were doing this problem and I weren't teaching it to you guys for the first time, I would probably do multiple rows at the same time, trying to get rid of that 2 that we just got rid of that became now this 0. But I'd also probably try to get rid of that 1 at the same time. The nice thing is we don't have to do them separately. We can do them all at once. But since we are doing them separately, let's see if we can get rid of that 1. So what I'm thinking, to get row 3, or to get rid of that 1 in row 3, let's do plus negative row 1. So we're going to do add the opposite of everything in row 1. And we're running out of room horizontally, so I'm going to zoom and shift a little bit here. So we're going to bring it all the way over, and if it helps you visually, I'm going to draw an arrow. Oops. Kind of curve that through, and our new matrix is going to be over here. So we're going to take that first row. We're not going to change anything with it right now. We're just going to rewrite it. So our first row is still 1, 2. Oops, sorry, I forgot to write it in matrix form. 1, 2, -1, 0, and on the other side our constant of 2. Second row, we're not dealing with that right now. We got 0, 1, 1, -2, and -3. Third row, we already dealt with that one a little bit, so we were we were left with 0, 0, 3, -3, and -6. And now we're going to actually do that operation of adding negative row 1 to that to that third column. So what I mean by that is we're going to take -1 times this, so -1 plus 0, giving us now 0 there. Then we're going to move on to the second column. We got 2 times -1, which is -2. Add it to that -4, we're going to get a grand total of -6. Moving on to the third column, we're going to have -1, or the opposite of -1. So that one we're going to multiply, waiting for it to show up again. Sorry. -1 times -1 is +1. Add that to -7, so we're going to get a -6 there. Waiting for it. Waiting for it. Sorry, I don't know if it's my computer or if it's my internet today. There we go. And we're going to move on to the next one. We got 0. We're going to take the opposite of that, which is still 0. And we're going to add it to the -1 down here. So there we go. 0, adding it to this -1 down here. And we're still going to get 0, or sorry, -1. And we're going to do the same thing for our constants. Okay, looks like we're back in business now. So we got the, again, we're adding the opposite of row 1 to everything in row 3. So now we have 0, 0, sorry, 0, -6, -6, -1. And then finally we got to add the opposite of 2 to -19. So the opposite of 2 is -2. Add that to -19. That gives us a whopping total of -21. So what we have so far is looking pretty good. We have a leading 1 up here, and again, behind or above and below our leading 1s, we want 0s. So we got 0s down the line there. Now, the next one, our leading 1 is going to be a little to the right of it, so that leading 1 is right there. We want to make sure we have 0s below that. Well, we got a 0 below that. That's not bad. We also have a -6 down there, so we're going to try to get rid of that. So, to get rid of that, let's take row 3 and add 6 times row 2 to it.
So we haven't changed anything with row 1 or 2 or 3, so let's just rewrite those. I feel like I've been saying those out loud, but for time's sake, I'm not going to say them. I'm just going to rewrite them. So we go. And then our constants. 0. I said I wasn't going to say them, and here I am saying them. It's hard for me not to talk while I'm writing. 0, 0, 3, -3, -6, and then finally we're adding 6 times row 2 to row 4. So we're going to take everything in row 2, multiply it by 6, and add it. So we're going to take the 0, multiply it by 6, and add to that 0. That's super exciting. That's still 0. We're going to take the 1 here, multiply that by 6, giving us +6, add it to that -6. That also gives us 0, which is kind of the whole point. Now we're going to take this 1, multiply it by 6, and add it to this -6. That's also going to give us 0. Well, this is working out pretty nicely. We're going to take this -2, multiply it by 6, giving us -12. Add it to this -1, giving us a grand total of -13. And then for our constant, we're going to take this -3, multiply it by 6. We're going to get -18. Add it to -21. That's going to give us a whopping -39. Now that looks like a nightmare, and I tend to agree, but it's actually not as bad as you might think. That bottom row, remember, we're trying to get all 0s and 1s. We got a bunch of 0s there. We want to make that -13 a 1. So the easiest way to do that would be just to divide the whole thing by -13. Now looking at the row above that, we also want to make this 3 in the long term, we want that to become a 1. So let's just divide that whole row by 3 while we're at it as well. So this is a case where we're going to do multiple operations to the matrix at the same time. So leaving the first 2 rows alone, we still got 1, 2, -1, 0, and then our constants. Oops, sorry, that was a little messy. 2. Second row, we got still 0, 1, 1, -2, -3. Third row, we're dividing everything in there by 3. So 0 divided by 3 is still 0. 0 divided by 3 is still 0. 3 divided by 3 is 1. -3 divided by -3 is -1. And then we have that -6 divided by -3 divided by 3 giving us -2. Bottom row, we're dividing everything by 13. So that gives us -13. 0, 0, 0. -13 divided by -13 is +1. And -39 divided by -13 is +3. Now, folks, I kind of locked myself into a wall here, so that's not an expression. What did I just say? Anyways, taking a look at this, we're going to start picking away. We got the bottom row to be 0, 0, 0, 1, 3. Effectively, what we just found is the value for W. So, the value for W is, ignore that, that was just Mrs. Benson. Trying to figure out what that was anyways. But we ended up solving for W there. That's W equals 3. So now we're going to kind of work our way back up just like we did last unit. So again, to recap, we're kind of trying to get this, we're trying to get this in row echelon form. We're trying to get our 1s on our diagonals here, which we have. Let me redraw that line there for our constants. So this is now finally in row echelon form. Now we're going to kind of work our way back up because we have 1s on our diagonals And looking up at the top, we want zeros below those ones, but we also want zeros above those ones. So we're going to kind of work our way back up, just like we did last unit. And in order to do so, I'm just going to zoom in here a second. Let's focus on just getting rid of that -1. So what I'm thinking we should do, let's add row 4 to row 3. So in doing so, I'm going to write this a little bit smaller. I'm going to put this over off to the right side here. We're just going to leave, or sorry, the left side, goodness gracious. We're just going to rewrite that first row, 1, 2, -1, 0, and then we're going to have a spot for our constants. And our constant for that row is just 2. Then for the second row, still 0, 1, 1, -2, -3. Now the third row, we're going to add everything from row, sorry, I miswrote that as well. Good night. Learn how to write, Brasser. But we're going to add row 4 to row 3. So we're going to add row 4 to row 3. So we're going to take everything in row 4, so like starting off with 0 plus 0, that's super exciting, that's 0. The next one's also 0 plus 0. Then we have that 0 plus 1, and now we're finally up to the point where, oh, sorry, 0 plus 1 is 1, my gosh. And then we're going to add the -1 and the 1 to give us 0. We also got to make sure we add our constants, so we have the -2 plus the 3 over here, giving us a grand total of +1. Bottom row still 0, 0, 0, 1, with a constant on the other side of 3. So, kind of again, keeping this in perspective, so far, the bottom row has told us that, or we've solved for w there. Now we know that w equals 3. The third row, the second from the bottom, that's like our z location. This here is our z column. So we have 0x, 0y, plus 1z, plus 0w equals 1. So now we know our z equals 1. Let's keep picking away at this, seeing if we can get some other zeros in here. What I'm thinking, let's take a look and try to get rid of this one here, so that right above that one. So let's add plus negative row 3. So we're going to add the opposite of everything in row 3 to row 2. First row, we're not tweaking it at all, so we're going to leave it as 1, 2, -1, 0, and then our constant of 2. Second row, we're going to do the column by column, adding it to row 3, so 0 plus 0 is still 0. 1 plus 0 is still 1. But we're also making sure we're adding the opposite, but we're opposite of 0. So we got 1 plus the opposite of 1. So it's 1 plus -1 giving us 0. Next column we have -2 plus the opposite of 0. Well, that's just still 0. So we have -2 plus 0 giving us -2. And in that final column we have -3 plus the opposite of 1, so plus -1, giving us a grand total of -4. We didn't tweak anything with the third row, so it's still 0, 0, 1, 0, 1. Final row 0, 0, 0, 1, and 3. Okay, getting a little cleaner. We got some more zeros. Kind of nice. I'm thinking, let's see if we can get rid of this -2 now. So to get rid of that -2, let's add 2 times our final row, 2 times row 4. Now going column by column again, well, let's rewrite that first row. 1, 2, -1, 0, and then a constant of 2. And then second row, now we're adding everything, 2 times everything in row 4. So going column by column is 0 plus 2 times 0, that's still 0. The next one is 1 plus 2 times 0, that's still 1. We got zeros, still 0. And then finally in that last column before the constants, we have -2 plus 2 times 1, that gives us what we're aiming for, that 0. We also got to do the constants, so we have -4 plus 2 times that 3, so -4 plus 6 giving us +2. The bottom 2 rows haven't changed this round. Okay, now looking at that second row, we only have 0, 1, 0, 0. Remember, that column is our y column, so now we have y, 1y equals 2. So that means we're pretty darn close to being done here. Thankfully, because these problems can be quite tedious. So now we're going to work on that top row, trying to leave that 1 alone in the corner here. Then you got to get rid of that 2 and that -1. Doesn't really make a difference which one you do first. I'm going to do, well, let's do that 2 first. So to get rid of that 2 first, what I'm thinking is let's take -2 times row 2. So do plus -2 row 2. And in doing so, that first column, we're going to have 1 plus 2, or sorry, 1 minus 2 times 0, still 1. Then we have the next column, we have 2 plus negative 2 times 1, so 2 plus negative 2 giving us 0. Then we'll have negative 1 plus 2 times 0 giving us still negative 1. Then we have zeros in the next column. When we add those together, it doesn't matter what we're multiplying by, they're still 0. And then for that constant, we're going to have that 2 plus negative 2 times 2. So negative 2 times 2 is 4, added to that 2, sorry, negative 4, added to that 2, we get negative 2. Second row, no change. Third row, no change. Fourth row, no change. Okay, we're almost done. Taking a look at this, and I'm kind of running out of space. Let me shift this a little bit so I can write a little bit off to the right here. So we've got to get rid of one more thing. We got to get rid of that negative 1. So to get rid of that negative 1, let's add row 3 to that top row. So we're going to do plus row 3. I'm sorry, it's a little crammed there. Let me zoom in on that. So it's plus row 3. So we're going to take everything in row 1, add it to row 3. So just kind of verbally going through it, and I'll start writing in a second. We're going to do 1 plus 0, it's still 1. 0 plus 0, no change there. Negative 1 plus 1, that's where the change starts to happen. So going through that, again, the first column, the 1 plus 0 still gives us 1. The 0 plus 0 is 0. Negative 1 plus that 1 from row 3 is 0. Then row 1 and row 3, add the zeros together, we still get 0. We also got to make sure we add our constants. So in row 1, we had negative 2, and we're adding row 3 to it, so it's negative 2 plus 1 giving us negative 1. We're not changing anything with those last 3 rows, so let's just rewrite those. 0, 0, 1, 0, 1, and 0, 0, 0, 1, 3. Folks, that is as far as we need to go. Now let me make sure this line is a little more dashed so that it doesn't look like it's a bunch of constants, a bunch of 1s. This is reduced row echelon form. And I was kind of talking about this as we were going through the problem. Reduced row echelon form gives us our solutions for our variables. This first column, again, this first column here represents our x's. So we have 1x, 0y, 0z, and 0w. So essentially 1x equals negative 1. So if we're putting this as a solution, our x value is negative 1. From the second row, we find out that y equals 1. From the third row, or sorry, the y equals 2, goodness gracious. From the third row, we end up with z equals 1, and finally our last row, w equals 3. That is a lot of work. It's tedious. You're bound to make mistakes at some point. If you saw how many times I paused this video, you would realize that I make mistakes too. Take it slowly.